Good day to our thesis advisor, Engineer Jerry I. Teleron, to the panelists, the chairperson, and members. I am Rickster J.T. Raliza, and I would like to greet you all a pleasant day. Today, we will presenting an experimental study of soil stabilization using recycled geogrid reinforcement, together with my group mates, Mr. Chris Alron Chato, Mr. Ryan R. Villa, and with our co-author, Engineer Richard Badiola. So, soil stabilization using recycled geogrid reinforcement, an experimental study with a code to achieve an eco-friendly environment and to see a free waste future. This study is to produce geogrid out of plastic waste material and used to stabilize road foundation. So the state of the soil plays a vital role in supporting any structures. Geogrid, as a material that has been used for any road-related construction, has been helping the stability of the pavement. Due to the increasing number of disposed waste every day, this research is to make geogrids out of recyclable plastic materials. Biaxial geogrid is manufactured using the plastic waste materials and is then tested to observe its performance under differential and vertical loadings. Geogrids have been known to help in the soil stabilization. This is a material that is used mostly in road pavements. It is made out of polymeric materials which primarily have two classifications, the uniaxial geogrids and biaxial geogrids. These categories later developed to produce more upgraded version, which is the triaxial geogrids. Uniaxial geogrids give contribution in terms of tensile strength in one direction approach, while the biaxial geogrids allow the scope of tensile strength in orthogonal direction. So the benefits of using geogrids for the stability of soil are known to be wide. This helps in the solution of subgrade in soil condition and maximize the control of settlements. It also reduces the soil for backfilling and lessens the needs of aggregates for layer works. This also improves the load-bearing capacity and reinforces the base layer. This has a higher ability to distribute loads over large areas, which is accompanied by a great performance intention. So every day, tons of waste are being multiplied, especially in this time of pandemic. Medical waste like face mask and face shield, which is becoming part of the new normal, is exponentially increasing. So this waste led the researchers to incorporate plastic waste to soil stabilization. Given that geogrid are formed from polymers, researchers will produce geogrids out of those plastic waste. The performance of a factory manufactured geogrids will be compared, which will give a greater performance when it comes to soil stability. So, structural analysis for the theoretical framework, soil mechanics, environmental engineering, and values engineering are the few anchors that help support the study in consideration of the relevant principles that can be contribution to the researchers. So, the conceptual framework of this study is input, data gathering, plastic waste collection, process, preliminary design of geogrids, geogrid form and dimensions. Output is the biaxial geogrid. So that's the flow chart of this project study. So the general objective of this study is to manufacture geogrids out of plastic waste materials and stabilize road foundation using geogrid from recycled densified plastics. Specific objectives of the study is to characterize the soil foundations in terms of index properties and relevant engineering properties, to test the performance of recycled geogrids such as tensile, compressive strength, etc., to analyze the road-based foundation using the geogrid.
Methods. As you can see in the picture below, we have a block diagram of the project. In every study, it is important to always gather the right data needed for the study. In making geogrids, data regarding its composition and form is needed in order to produce a geogrid that conforms the code of the country. Then right after is the preliminary design. then perspective, then analyze and design, product testing, then the result and findings. Project development flow. There are plenty of things to be considered in making a geogrid. Data like desired form and dimension must be specified. The data will not only involve formation of geogrid but also in a performance of the structure. The preliminary design is constructed after the essential design is gathered. After a preliminary design, the perspective is presented to visualize the rail biaxial geogrid. This is to clearly picture out the product after being formed. The design will be analyzed if it can withstand the loadings that it will receive. This will also help determine the maximum loading it can carry. The geogrid will be formed and produced physically using the plastic waste gathered and recycled. The results and findings are drawn after the thorough investigation and testing of the product. These findings are relevant for the researchers to determine if the plastic waste is an effective alternative to the original materials used in making geogrids. Then, the data collection procedure. The figure above shows the flow of the project experimental design. The experimental design of the proposed stabilization of soil using recycled geogrid will serve as the guide to conduct the study. Conducting survey, designing the prepared geogrid which present economical, alternative, and eco-friendly resource, which reduces disposal problems, analyze to ensure the effectiveness and efficiency in reducing waste material, evaluate using densified plastic waste and performance of materials used in the design, and propose the sustainability and advantages in terms of using recycled geogrid for the reinforcement.
So, for the results and discussions, we use 3 molder for production which only differs on its thickness, which is 6.35, 12.7, and 20 mm. So, collection of PP and shredding. Polypropylene is a thermoplastic addition polymer made from the combination of propylene monomers. It is used in a variety of applications to include packaging for consumer products, plastic parts for various industry including automotive industry, special devices like living hinges, and textiles. So these are the properties of polypropylene. So using PP geogrid production experiment, no temperature versus time reading. So as shown, the result is nowhere near the probability for laboratory testing. It's flaky. So using PP geogrid production experiment with temperature versus time reading. So the chart given is temperature versus time. So time is measured by minutes and the temperature is by centigrade. So the detailed production is put in the manuscript. So using 20 mm thickness. So the result of plastic appearance is candy-like. Due to its thickness, is prone to breakage when bent, and it is not durable enough basing on actual, not prior to laboratory testing. So it failed. Using 12.7 mm thickness. The physical appearance is the same as the first try. It has a bubbly appearance too, and it can bend a little but cracks after, just as shown on the picture. Neither durability nor flexibility is achievable, so it is also a failure. So the third attempt is using 6.35 mm thickness. So it has the appearance of the same as the first and the second, and has bubbly and small pores. It can be bent and has durability not basing on laboratory test, just the researcher's observation. The characteristic is met, but it lacks in terms of strength and further bendings. The experiment needs more improvement to able to obtain the result that is good for laboratory. So it also failed. Due to pandemic, the researchers are limited on motion and were stuck on the materials provided by the only landfill available on the city. So, based on the results for the design, fabrication, and production, geogrid production needs further sampling and testing to obtain the target result. The researchers were unable to finish the experimental study to come up with a better result of production. So, our conclusion. The researchers conclude that the experimental study on geogrid production failed and needs further tackling. It is observed that the property of plastic relies on the temperature. Thus, machinery is very important in conducting production to be able to monitor the reading of temperature. The design of geogrid must have a thickness less than 10 mm to come up with a flexible outcome based on our observation. The geogrid that the researchers produced were unable to be tested on laboratory for its strength and flexibility. Furthermore, the characteristics of a biaxial geogrid are flexibility and durability that were able to support the load for soil reinforcement. So our recommendations for the future development and betterment of this study, the researchers recommend plastic melting shouldn't be done without prior monitoring of the temperature. That is, never do it as what we've done on the first experiment, because the output always failed due to plastic is somehow just like a glass, it is fragile in some ways. So geogrid production must both attain flexible and durable results, so it is important to design taking into account the said properties. So the geogrid produced by the researchers did not undergo laboratory tests to conclude its effectiveness for soil establishment, so the future developer needs to test first. CBR test must be done for variation between with and without geogrid in terms of compaction. There are various plastics and other recyclable materials that can be of use for production. Allow researching furthermore to what you've acquired already to come up with a more obtainable promising outcome. So our references are the following. Thank you, and